Right, for the last bit of this chapter, we're going to look at power. Now, in terms of the textbook, this links with page 77 onwards. So, the idea of power is that power is the rate of work. So, it's an amount of work done over, or how much work we're doing per time. So, the units for power is watts, which is the equivalent of 1 joule per second. 1 watt is the equivalent of 1 joule per second. Now, as always, make sure you're confident with those units, because if you're struggling with anything, you can always fall back on those units to give you a bit of help. Now, a specific use of that we're going to be looking at is this one, to do with a car engine, or any type of engine for that matter, where the power produced by the engine, or whatever it may be, is equal to the amount of force it's producing multiplied by the velocity it's travelling at. Now, this has a couple of consequences that are worth considering. For example, if we keep a constant power, then a couple of things can happen. If the power stays the same, the higher the velocity, the smaller the force that's being produced. Okay? And similarly, for a fixed velocity, if we want to increase the force, we need to increase the power. So it's really useful for explaining what's going on in a situation. Now we're going to have a look at an example. So here I've got a car engine producing 2,800 watts of power. It's travelling at a constant speed on a horizontal road. What is the total of the resistive forces? So we're not splitting the resistances up, we're just dealing with them as one. Now, because we're horizontal, that means we don't have to consider gravity, which is nice. So here's our car. Artist to the end. We've got our resistance that way. We've got a velocity that way of 8 meters per second. We've got power of 2.8 kilowatts, which will produce a force going forward. Now, as we're at a constant speed, we know that the zero acceleration, so resolving horizontally, we know F minus R equals 0. So the force produced by the engine is equal to the resistive forces. Now, we also know from further up that the power is equal to the force times the velocity. So all we have to do here is say 2,800 is equal to 8 lots of F. So we divide that through, and that gives us F is equal to 350 newtons. Therefore, R is equal to 350 newtons. And we're done.